video, we're gonna draw a state diagram of deterministic finite automaton to recognize this language that is gonna begin with a 1 and ends with a 0. So to solve this problem, the best thing is to come up with some strings that is in this language. So, okay, let's write some possible strings. So, okay, so first it's gonna start with a 1 and ends with a 0. That's the simplest or easiest or smallest string that could be in this language. Well, another could be 1 0 0 or 1 1 0, right? Both starts and ends with a 1. Starts with a 1 and ends with a 0. Another could be 1 0 0 0 or 1 1 1 0 or 1 1 1 1 0 0. Does not really matter. As long as it starts with a 1 and ends with a 0, it should be in the language. But what if it starts with a 0? If I have something like that, 0 0 0 1 0, should I accept it? Well, I shouldn't, because it's gonna first, when I see it's not gonna start with a 0, I'm not gonna accept it. Even though it does ends with a 0, does not really matter. It has to be starts with a 1. What if it starts with a 1 but ends with a 1 as well? Well, I'm not gonna accept it, even though it starts with a 1 but has to ends with a 0 as well, so I'm not gonna accept it. So let's try to draw a state diagram of deterministic finite automata for this language. First of all, I'm gonna have a start state. So for DFA, or deterministic finite automata, for every state there has to be two transitions because there is only two languages here. Two alphabet here given, 0 and 1. For two alphabet, it's going to be two transitions. If there's three alphabets, it is going to be three transitions. For our problem, there has to be two transitions, one for 0 and one for 1. Okay, so what if we see a 0 first? Let's say for 0, what are we gonna do? Well, if I see a 0 first, I know with just to see the 0, it's not gonna end up in a accepting state. That means that I'm not gonna accept this string just because it starts with a 0, because it's there in the language. It has to be begins with a 1. So for this, I'm gonna go to a state, and it's not gonna be accepting state. It's gonna be a non-accepting state. So I'm gonna go to a state. Let's just say this is a sync state. Let's say that's n. So this is a sync state. It means that I'm not gonna go anywhere from this state. So, okay, let's just say if I see a 0 and 1, I'm just going to be in that state. Because if, if my a string is something like that, starts with a 0, but what if I see 1, 1, 1, 0, 0, 1? Really doesn't matter what I see after that. I'm just gonna be thinking, because it starts with a 0. So if it starts with a 0, I go to a sync state, or go to a state that's not gonna be accepting state, and I just stay in that state. Doesn't matter I see a 0 or 1. It's never gonna be accepting state. Okay. I can name the states. Let's say this is 1 or this is 5 maybe. The naming convention really doesn't matter in this problem. You can name your states whatever you want to name. Okay. So what if I see a 1 in my starting state, or state 1? Well, that does make things easier, because if I see a 1, I am going towards the easier path. Okay, what if I see a 0 right after that? What if I see a 0 right after that? Well, then I should be end up in accepting state. So easier way to think the problem is, just when you start starting state, I see a 1, I go to a different state. I see a 0, I go to a different state, and I accept. Okay, that's the just easiest way to think. Let me name this state. This is 2 and this is 3 maybe. Again, naming convention doesn't really matter for this problem. You can name your state however way you want to. It's really not going to be matter. Okay, so on my state 2, I have a transition for 0, but now I need a transition for 1. Now think about it. If my string is something like that, like 1, 1, 1, 1, 0. It does starts with a 1, but ends with a 0. But I have a bunch of 1s in the middle. What I do? Well, I just stay in this state, because, well, if my string is just 1, 1, 1, should I go to a final state? Of course not. I have to be in a non-final state. So if I see 1, I go to state 2. If I see another one, I will be in the state 2, and if I see another one, I will be again in state 2. So it's a self loop to state 2. The transition will be to its state as a self transitions. Think about something like that. Okay. So then state 2 has 2 transitions, that is 0 and 1. Now what about state 3? Well, what if my string is something like 1, 0, 0, 0, 0? What I'm gonna do? I should accept it, because it starts with a 1 and ends with a 0, right? Okay, let's see. It starts with a state 1. When I see a 1, I move to state 2. When I see a 0, I move to state 3, right? If I see a 0, again, what should I do? Let's just say I stay in state 3, okay? For now, let's just say this, okay? Because let's say my string is just 1, 0, 0. So for this, just for this string, it has to accept, right? Because I am gonna end up in a I'm gonna start with the 1 and ends with the 0. They technically should accept. Okay, what if for this string, what if I see another 0? I stays in here. What if I see another 0? I stays in state 3. So technically, theoretically, and practically, both ways, this string should be in the language, so should be. That's how we have to design our DFA machine. All right. So state 3 has transition for 0. Now we need a transition for 1 on state 3. Okay. So now, what if we have a string like okay, so we have a string like 1 1 0 0 1 0. Okay, well, I should accept it because it starts with a 1 and ends with a 0, but let's check it out if my machine would accept it or not. Think about focus on this thing that I'm trying to figure out what my transition for 1 is on state 3. Okay, so on state, we'll start with state 1, I see a 1, I move to state 2, I see a 1, I remain in state 2, if I see a 0, I go to state 3, if I see another 0, I remain at state 3, if I see 1 now, that makes things something interesting. So let's just say I'm gonna go back one step. For 1, I'm gonna go to state 2. Now think about it. Now, well, was it a right decision or not? Well, it was the correct decision because let's finish this string and then talk about this. And then I see a 0, I move to state 3, and state 3 is the final state. Now, let's say something like 1 1 0 1 1 1 0. So for this string, let's see if this string is accepted by this DFA or not. It should be, because it starts with a 1 and ends with a 0. So if I see a 1, I go from state 1 to state 2. If I see another 1, I remain in state 2. If I see a 0, I go to state 2 to state 3. If I see another 1, I am gonna go to state 3 to state 2, correct? Yes, I'm going one step back. If I see another one, I will stay at state 2. If I see another one, I will stay at state 2, because it's a self loop, right? And if I see another 0, I'm gonna go from state 2 to state 3, and state 3 is the final state, and that is the end of our string as well. So this string is acceptable by this DFA. So I mean, you can go ahead and try with one of the non-accepting string, something like that. Let's consider this string. So 0, I'm gonna go from state 1 to state 5, and then for another 0, I will be in state 5. Another 0, I will remain in state 5. Another one, I will remain in state 1. Another 0, I will remain on state 5. So this is a very easy, the sync state. Once we can dismiss that if my start is a 0, so I can dismiss it and take it to a state that is never gonna be linked, or that is never gonna be at a final state. Okay, then we can probably check out one more, this example that's not going to be accepted by this DFA. Okay, so if I see a 1, I go from state 1 to state 2. If I see a 0, I'm gonna go to accept 3. If I see another 0, I will remain in state 3. If I see another 0, I will remain in state 3. If I see another 1, I'm gonna go from state 3 to state 2, and that's where I end, and state 2 is not a final state, so this string is not gonna be accepted by this DFA. So yeah, this is the right DFA for this language. If you have any question, ask me in the comment section, and thanks for watching the video.